Hi everyone, my name is Nick. I'm a software developer from 1inch, and right now I want to talk about our APIs, about our limit order API and about our aggregation API. But firstly I want to talk about our project a bit. 1inch network is actually consists of multiple protocols. The main protocol of 1inch network is Aggregation Protocol, and currently we have more than 2.7 million users in our across multiple EVM compatible chains. We have billions of volume on our exchange, on our aggregation protocol. We also do support most of the EVM chains, and we also support most of the DEXs across all the EVM chains. Aggregation protocol is basically the idea how we can aggregate all the liquidity across all the DEXs and allow users to swap with the best rate on the market with the same experience, with the same user experience as on the Uniswap, for example. So basically, this is like short overview of all our protocols. We do have our 1inch wallet, we do have DAO, we do have token. Currently, we also have limit order protocol and liquidity protocol. And we're also working on 1inch Pro that is basically regulated solution for the institutionals. That allows you to swap with KYC, with all the support, with all the regulations. Let's talk a bit about aggregation protocol. So basically, aggregation protocol, as I said before, allows to get the best rate on the market across any chain. Let's just think that you need to swap, for example, like 100 Ethereum to DAI, and basically firstly we'll go to Uniswap and try to swap there. And what if I can tell you that you will always have the better rate on 1inch exchange, because we aggregate multiple providers, also Uniswap, Curve, almost all the DEXs that you have on any chain, and allows you to get the best rate. We also have very optimized gas router. So basically, it's always the best way to swap is always to aggregate multiple DEXs. And we do all of the stuff on the same transaction. So you have the same user experience as swapping just on Uniswap. So like the main idea of aggregation protocol that you have multiple parties here. Basically, we allow you to use our API to get the rate as a developer. You just need to ask for the quote. You need to pass some, like to build some data for the quote. You ask for the quote on our API. If you are agreed with the amount of the return amount of the quote, you need to ask for the call data for the transaction. After you build the transaction using our swap method, you basically just need to pass this transaction to the smart contract. So you just, after swap, you need to go to the smart contract 1inch route of 1inch. It's called 1inch router, and just pass the data that we gave you on the previously. Our 1inch router supports actually multiple swaps, and we do it on like actually. I mean that it can be executed parallelly. We can execute swaps between any token to any token, and even if some of the part of the swap will fail, we still allows user to continue to swap it. So some percent of the swap can go back to the user, to the executor, and the main part will be swapped with this rate. We also support min return amount. So basically, 1inch router allows you to actually to execute any type of the transaction for user, whatever user wants. And the most interesting stuff about 1inch router that is much more optimized than a Uniswap router. Even if you do just simple swap via Uniswap, it will be much more cheaper using just 1inch router for that. So you will always save on gas more than on Uniswap with us. Basically, if you want to integrate 1inch aggregation protocol API, you just need these two methods. These two methods are available on our 1inch docs site. So basically, the first one is 1inch quote, as I said before. The second one is a swap. I just want to talk about all the params that we have on the quote and on the swap, all the query params. Basically, you just need 3 query params to make a swap, to get a quote on 1inch. It's just from token to token address and also amount. That is basically amount of the from token address. So this is example of these examples are of the examples of swapping Ethereum to 1 inch, of 1 Ethereum to 1 inch. Basically, all these params allows you to get the quote. You don't need to think a lot about which params you need to pass, just the tokens and amount. But we do also support multiple other additional parameters that allows you to do more custom logic for your client. So I want to talk about that. Firstly, we support protocols param. This param allows you to specify specific dexes that you need for exchange for the swap. Sometimes you want to swap only on specific dexes for a specific pair, and it can be useful for low liquidity pair tokens. Usually we do support all the protocols, but you can turn off some of them and also have a bit more faster response. We also support fee. Fee allows any protocol, any integration to have some reward fee for each positive slippage from the user side. This fee can be up to 3% per swap. It depends on the execution of the transaction. If there is no positive slippage, you will not get the fee from this transaction. But if it will be, you can earn up to 3% from the user. So by default, the fee is 0%. But if you want to specify something not differ from 0, you just need to pass a number from 0 to 3. We also have a parameter called connector tokens. This parameter is pretty important because that's one of the most base how we build path for the swap. Sometimes if you have no low liquidity token and you know specific pool, for example on Uniswap exchange, where there is a lot of liquidity for this token, if you will pass this connector token to our API, we will give you much more better return rate than if it will be just default connector tokens. So it's pretty important parameter for the very low liquidity tokens when you need to get the best return. We also have basic parameter is just gas price. If you will have pretty high gas price, it will be much more easier to get good return. So you can it depends on how much gas price you will pay. You will get different return amount. And we can adjust to the client. Sometimes users needs to pay a lot for the good swap because users can swap hundreds of Ethereum. Sometimes you need just to pay a couple of dollars, so it's almost like nothing. And we can optimize to each user. We can adjust to each of them. This is basically example of connector tokens here. On this path, it's USDC and Ethereum. I just want to visualize the idea of connector tokens. So for example, and the main swap is actually between DAI to ETH. And we have USDC and Ethereum as connector tokens. So if you will specify something else, for example, like 1 inch connector token, we will try to find the path to swap from DAI to 1 inch, and after that, from 1 inch to ETH, for example. And there is another parameter called complexity level. This parameter is pretty important because we can specify how much parts, how much we can go to the roads. Sometimes we can make just one connector token. Here, the complexity level is here because we use 2 connector tokens between swap of DAI to ETH. You can have up to 3 complexity levels on the swap. Usually, it's not very important to have 3. The complexity level of 3. Usually, 2 is pretty optimal solution. Sometimes you need a complexity level of 0 or 1 if it's very low gas optimized swap. Another very important parameter is main road parts. Basically, this is max amount of splits that you can make for each subpath from the from amount. It can be up to 50. Usually it's 10, but in the current example it's just 5. Basically, that means that we can split your DAI amount on each path to 5 parts to swap on the multiple dexes to the USDC, for example. We'd also have another parameter called parts. So we can split your subparts to another subparts during each swap. And you can also specify this parameter. You also can, by default, it's like 50, but sometimes you can specify it lower, so the response time will be much more lower and faster. Basically, after you can specify all the parameters for the quote, you need to do the same for the swap. And if we are talking about the swap method is pretty the same as quote, actually. You have all the same parameters, except some news. One more new parameter is slippage. And it's a very important parameter because sometimes when you do a swap, during transaction execution, the rates can be differ, and you can get much more lower amount of Ethereum, for example, in this example, than you expected. So you can specify how much percents of Ethereum, how much of the return amount you can lose, and you are okay with that. For example, in this example, I just specify 39%. That means that I can lose up to 49% of the Ethereum on the return rate, and the transaction will be still executed. It's very important to understand that if you will have very low slippage, you will also you will also have fail of your transaction because the price is going up and down too fast sometimes, and if the slippage is too low, it will be always reverted. So it's like always balance between very high slippage and very low slippage. It depends on the token pair and depends on the market conditions. Sometimes, it's usually if it's very hard to swap with the low slippage, you need to adjust it, to raise it a bit, and try again and again. It's pretty okay if you are using, for example, flash swaps, like flash bots for that. In this case, you just don't pay for gas, and it will be easier for you just to adjust slippage of your swap. Another important parameters is destination receiver and refer address. Basically, we do allow to specify return address that will be used to receive the funds from the swap. For example, you want to swap from one wallet and get funds to another wallet. It's possible via our router. It's also possible to specify the refer address. You need to specify this address if you want to get some fee commission for your integration. So, for example, if you are a wallet and you want to integrate one each API, and you want to get some commissions, you always need to specify address that will get some rewards, and also specify the fee amount % as well. Our router also supports permit. So basically, if your token supports permit, you can swap transaction. You can just swap without any approve, and you don't need to spend gas on the approve. You can do it in the same transaction as a swap. And also, we do specify gas limit. You can specify gas limit. Depends on the gas limit amount. We can adjust the road of the path. So if gas limit is very low, it will be pretty simple swap. And it's also pretty useful for low liquidity swaps and and for small amount swaps. There is also one important parameter called allow partial fill that allows you to, for example, to fill specific parts of the road of the swap, not the whole swap, just, for example, 70% of the swap. So basically, sometimes it's very important for you to swap at least something, and you are okay to swap at least 70% of the whole amount that you are going to swap, and all the other parts will go back to your account in the source currency. For example, in this example, if I will swap DAI to wrapped Ethereum, for example, like up to 90% of the swap goes to wrapped Ethereum, and the other 10% of DAI goes back to my address. But I will swap at least 90% of my amount to the wrapped Ethereum with the pretty good rate. It's very hard to swap big amounts of tokens with low slippage, but you can always try at least to fill small % of it. So it's also possible with our API. It's also a very important parameter called disable estimate. It allows you to specify. Sometimes you need to estimate transaction on the wallet, and sometimes it's impossible to do this because the wallet is not ready for that. For example, you need to estimate. You need to build call data for the swap, but this wallet doesn't have allowance for this token. In this case, you need to use disable estimate flag. So we will not estimate the transaction execution from this wallet, and you can just use this call data later for the swap. It's also important for the smart contracts. If you can always use another smart contract as a from token address, as a from address for the swap. So basically that's it about aggregation protocol, and I want to talk a bit about limit order protocol as well. Aggregation protocol is more about a user-side experience when you need to instantly swap some tokens. A limit order protocol allows you to specify the destination, or the rate, the rate of the swap, and the swap will be executed only with this rate. We do also support multiple additional features of a limit orders. It's pretty the same user experience as on any centralized exchange, but it's absolutely decentralized. What does it mean? For example, if you will create a limit order, you will not pay for the gas from the user side. You just need to create this limit order and sign it with your wallet with the specified rate. And any user can get your order and fill it. So basically, it's just agreement between someone and you that you are okay to swap some specific amount of the tokens with this rate. And anyone else can just fill this execution, this agreement, and just provide you these tokens with this rate, with this expected rate. And there is just smart contract that allows you to check all these conditions. It can be multiple conditions for each swap. So basically, with our limit order protocol, it's possible to implement multiple features like stop losses, like RFQ. Also, we can have dynamic prices. We can use arbitrary price discovery for each swap. The best example of it is that for each amount of tokens that you swap, the price can be varies, depends on the amount of the swap. It can varies, depends on the market condition. For example, I can create a limit order that is, and the rate of the limit order will be different, depends on the price of Chainlink, for example. So I want to swap, for example, wrapped Ethereum to 1 inch with the rate like 1 inch for like 0.1 Ethereum. But if the price of the Chainlink will be higher than $10, I want to have different rate. It's also possible with limit order. So basically, it's almost possible to implement any execution, any condition using our limit order protocol. There are two parties swap during limit order protocol. It's market maker and market taker. So market maker is the person who basically creates an order. You just create with some condition, and you need to sign it via your wallet. After that, you just need to share this order, this information with via 1 inch API with the whole network. And also, you don't pay for gas during this moment. If you don't have a allowance for the token, you don't need to pay for gas. You just create any order with any amount that is available on your wallet, and anyone else actually can fill your order after that. Another party that is responsible for actually filling these orders is market taker. It's anyone who can search for any available orders on our API. And basically, if this person is okay to fill this order, this person can just execute the swap and fill the order. Why it's important? Why market taker exists, and why do they need this? Basically, sometimes there is some limit orders with the market rate that is pretty profitable for the market taker. So market takers usually just earn some profits based on the limit orders. For example, the current market price of the Ethereum, for example, will be 2,000, but there will be limit order for 2,050. So it will be profitable for market taker just to execute such limit order and earn some profits on it. So basically, market taker also needs to calculate amount of gas that market taker needs to pay to execute this limit order. Basically, it's always market taker who pays for the gas of the limit order. Market maker don't need to pay for that. It looks pretty like this. Firstly, market maker just need to sign and send order to our storage of limit orders, to our API. It also can be absolutely decentralized. You can not use any API for that. You can just use P2P exchange for the limit orders. After that, a market taker search for suitable limit orders on our storage. After that, market taker can fill this limit order via our smart contract on chain, paying some gas for it. And after that, basically, market maker receives these tokens, like needed tokens, based on this order. So it works pretty simple, actually. Let's talk a bit about limit order structure if you want to integrate limit orders. We have SDK, we have JavaScript SDK for limit orders, so it's pretty simple actually to integrate and to use them on your site. But if you want to have additional conditions and if you want to go deep, you need to understand this information. Basically, the structure is like that. And I want to say about maker asset data and taker asset data parameters here. Basically, with our limit orders, we support not only ERC20 tokens, you can specify any other asset that can be implemented via maker asset data and taker asset data parameters. This data allows you to actually support any asset that will have their own method of transfer. So basically, you can, for example, specify NFT tokens, like ERC721 tokens for limit order, and implement, for example, NFT marketplace based on the limit order protocol. You just need to redefine maker asset data and taker asset data fields. Also, get maker amount and get taker amount fields allows you to specify the rate, the exchange rate of the assets. So it can be pretty dynamic rates, depends on the additional parameters that you can also specify. We do also support predicate and permit. So permit is pretty basic, it's pretty the same. It's also the same permit as we have on aggregation protocol. So you can swap without any fees if your token supports permit. And interaction field is pretty important field that allows you to make some callbacks. Actually, we use this callbacks before transfer from of the maker's tokens to the taker address. So basically, interaction allows you, for example, to implement such logic as, for example, to store all your tokens on the compound, and when the limit order will be executed, these tokens will be removed from the compound stake. They will be unstaked and will be going to the taker amount, to the taker. So basically, for example, with limit order, you can create an order and use your funds to earn some profits on the compound, for example, on the same time. And when it will be executed, they will just withdraw these tokens from the compound in the same transaction. So let's talk a bit about order execution. If you need to fill this order, you need to use a function called field order on the smart contract. And for that, you need to pass such parameters as the order structure, as I described before. And also you need to pass a signature. We do support sign type data before signature for that. And if you have a case when you have smart contract as a maker address, signature must be not a sign type data signature, but specific data that this signature will be sent to your smart contract, and your smart contract need to verify this data on its side, on its side, basically. So we actually support any address that can be market maker for the limit order. And basically making amount and taking amount are just amounts that you need for the swap. Based on them, you actually have a rate. And threshold amount is mean return that you can get for the taking amount. So if you are not okay to get at least if you are okay only to get at least 50% of the limit order, you can specify that using threshold amount. Let's talk about predicate. Actually, it's conditional execution, what I said before. We are using predicates, for example, to allow users to cancel the orders. If you will use predicates, you can allow users to cancel limit order during runtime, during some time. You can also specify timestamp for the limit order. So it will be alive only, for example, for 5 minutes or for 30 minutes. We do use predicate for that. We have basic implementations of some functions for limit orders, and you can use all of them. And actually, you can build your own predicate based on our basic functions. So it's pretty customizable. For example, if you want some additional condition, you just need to deploy smart contract to the Ethereum and implement specific functions there. And after that, you can just build limit order that just goes to your smart contract on Ethereum and checks some conditions there. So you can also, as I said before, you can redefine get maker and get taker amount. So basically, this is default implementations of getMaker and getTaker amount. But if you are not OK with that, you can always specify your own. Actually, that allows you to may implement your own price auction. So the price can go up and down, depends on your rules for each token and for each additional condition on the market. So that's actually how we implement execution of the limit order. So basically, that's how actually we do calculate your return amount. And it's pretty important to understand that to build your custom implementation of the getMaker and getTaker amount. If you have a case when your maker address is a smart contract, it's just not a simple wallet, for example, user, but it's some other smart contract. In this case, we will call this function. It's called isValidSignature on the address of the smart contract. So you need to implement this function on your site. Basically, we pass hash of the limit order, and also we pass the signature, which is basically any data that you can specify. So you need to verify this data on the smart contract side all the time that you create any new order. So if you will not have this signature, it will be not working. Or actually, all the functions will be working by default. It's also, as I said before, there is an interaction parameter that allows you to somehow to interact with the user funds, with the maker funds before transfer from to the taker address. So basically, using this function called notify fill order, you can implement any custom callback to any other protocol and somehow manage the maker funds. So it's pretty useful, as I said before, for example, for the case of the compound. So basically, that's all what I want to say. If you have any questions, we'll be happy to answer about that. There are just two important links that I put. The first one is actually a quick start for the limit orders. If you use a JavaScript SDK, or if you use JavaScript on the client side, and if you want to go deeper and you need, for example, to modify smart contracts for your and to specify specific conditions for the limit order, you need to go to the limit order protocol v2 GitHub and actually to try to use it on the Solidity side. We have all the tests there, all the information that you need to somehow use additional callbacks or something like that. So we'll be pretty happy to answer any of your questions, and thank you.